Hello and welcome to my office again. Today is Monday the 23rd of March, so yeah, let's see what happens. So I gave you some exercises to do over the weekend, so let's take a look at those exercises now. First exercise was, let's take a look at question 2. Let's take a look at part 5. And part 5 is 4 minus 2i. And from that we're going to take away 3 minus 7i. So we're doing this topic called complex numbers at the moment. And complex numbers have two parts to them. They have this real part and they have this imaginary part. So we have a complex number here, we have a complex number here. And we were looking at taking this complex number away from this complex number. So realistically we take the real part away from the real part and the imaginary part away from the imaginary part. But we need to be really, really careful because we have this sign here in the middle. So I'm effectively going to say I'm going to take this away and I'm going to take this away as well. So this is the first thing, and this is the second thing. So I'm going to take away the 3, and I'm also going to take away the negative 7i. So when I take away negative 7i, what am I actually doing? And I'm taking away a negative. What's going on there? Good. So I have a minus and a minus 7i. So I'm taking a taking. So it's going to be a plus 7i. So I have 4 take away 3, it's just 1. And I have minus 2i plus 7i is plus 5i. So that's my real part, my imaginary part, that's my complex number. So that's question 2, part 5. The next question I'm going to look at is question 2. Part VI, part 6. And that asked us, it gives minus 6, minus 2i, and from that we take away 5 minus I. So some things to note here. We have negative signs in this bracket over here. So we're starting with a negative 6, negative 2i. And we're taking away a 5. That should be fine. And then we're taking away an I. So technically, what number is in front of this I? We never bother writing it, but it's technically always there. Yeah, so that's technically minus 1i. We would never bother writing it, but it's technically a minus 1i. So I can now do my usual process on this. So let's take the extra step. Let's do this step again. We could jump straight to the answer, but let's take the extra step. So I have minus 6, minus 5, minus 2i. Then I have minus 5. Now, I'm taking minus 1i. So what's that? That's the same thing. If I'm taking minus 1i, that's going to be the same thing as adding 1i. So I have minus 6 minus 5, that's going to be minus 11. And I'm at minus 2i, and I add on 1i. So I'm at minus 2, and I jump forward when that gets me to minus 1i. And that's my complex number there. So that's the answer to question 2, part 6. Will you guys remind me to draw these lines? Okay, so that's the that was the kind of the hardest of the easy questions, and then there were some letters involved. So we'll take a look at some letter ones now. Okay, so the next question we're going to take a look at is question 2, part 10, and that tells us that x plus yi, that complex number, is being taken by p minus q I. So I would classify this question here as one of those questions that's just awkward for the sake of being awkward. You have the required skills in order to do this question, but it's probably just a little bit more awkward because there's letters instead of numbers. But we know our algebra, so we should be able to deal with these quite happily. So let's take a look at what we have. We have this x plus yi. So what's the imaginary part and what's the real part over here? So the real part is, okay, so the real part is the x, and what's the imaginary part? Good, it's the yi. And then what's the real part in this complex number? Good, it's going to be the p. And what's the imaginary part in this complex number? Yeah, it's going to be the minus qi. So that sign there is going to be very important because we have a minus out here, and so we'll be taking away the p, but we'll also be taking away the qi. Sorry, we'll be also taking away the minus qi. So we need to pay really, really close attention to the signs here. So let's get on to our first step. So there's nothing really happening to this thing here, so there's no need for that bracket really. So we can go x plus yi, and from him we're taking away p, and we're also taking away negative qi. So if we take away negative qi, that's the same thing as adding qi. And then to get on to the next line, I add or subtract my real parts with my real parts and my imaginary parts with my imaginary parts. So I need to now think about what's my real parts in here. My real parts are these two guys. So my real parts will be x minus p. And I cannot combine these two things together because they're two different letters. Right? We cannot add elephants and sheep together, right? So we have x's and we have p's, and we have to keep those two things separate. We cannot combine them with the operation of subtraction. So that's a real part. And then we have plus yi plus qi. Now if you guys can get as far as there, I'm very, very happy, okay? You're talking maybe 7 out of 10, maybe even 8 out of 10 for doing that, okay? There's going to be 2 marks for this last little step. And that's maybe to just show that we have a definite real part, which is x minus p. So that's the definite real part. I might put him into brackets. And we also have a definite imaginary part. So we have a definite imaginary part. So we have something that's going to multiply the I. And the thing that multiplies the I is the y plus the q. So I have factorized out the I. So I saw that there was an I in common between these two things here. So I've factorized it by pulling it out. So that will be our answer. That's my real part, That's my imaginary part. That's my imaginary coefficient. So that's the coefficient of the imaginary part. The entire imaginary part, though, the entire imaginary part is this thing in here, really. Everything in between my finger and thumb. So that's question 2, part 10. The next question I'm going to look at is question 4, part I, 4, part 1, and that's going to be an addition. So we're going to add Z1 onto Z3. So we're told that Z1 is equal to 1 minus 2i, and we're told that Z3, well, that's equal to 1 minus 3i. And I want to now add Z1 plus Z3 together. So let's take a look at that now. So I'm going to write it out. I'm going to write out 1 minus 2i, and onto that I'm going to add 1 minus 3i. And to get onto my next line, I can add my real parts with my real parts, and my imaginary parts with my imaginary parts. So I have 1 here and I have 1 there, so that's going to give me 2. And I have minus 2i minus 3i, so in total I have minus 5i. So Z1 plus Z3 is equal to 2 take away 5i. Real part, imaginary part. Just a very quick note on notation. When we were doing algebra before, we tended to use x's and maybe y's. They were kind of the default variables because the answer was going to be a real number. It's just convention that when we're talking about complex numbers, we tend to use z's as our variables. It's just kind of a tradition. So that's how we do question 4, part 1, the addition. There's no real need for brackets here because there's nothing going to change a sign or anything. The next question I'm going to look at is question 4, part 4. And we have Z1 is equal to 1 minus 2i, Z3 is equal to 1 minus 3i, and we're asked to find out what 2Z3 minus 3Z1 is equal to. So what this means is we haven't really looked at what these numbers on front of a complex number means. So they realistically, they just mean that if we have Z3 here, well, we actually have 2 of them. So it's going to be 2 times one minus 3i minus 3 bracket 1 minus 2i. So this thing here, that's Z3. This thing here, that's Z1. Okay, so I put some arrows in maybe to help you. And I have coloured chalk, but they're not great. So Z3 goes in here and Z1 goes in there. Next job. Can I do the subtraction yet? Am I ready to do the subtraction? Don't think so. Because we know that before we subtract this from this, well, we know that we have to do multiplication division because of BIMDAS, right? So BIMDAS holds. So BIMDAS, that thing we learned about, let's put those into boxes. Let's put that into a box. Put that into a box. So BIMDAS holds even for complex numbers. And BIMDAS tells us that before we do the subtraction, we must do the multiplication and the division. So we only have multiplication and division going on here. Sorry, we only have multiplication going on here. So let's do that multiplication now. So how do I multiply 2 by this thing here? going to be 2 minus 6i minus 3. Now, minus 3 by 1 is minus 3. Minus 3 by minus 2i. So minus 3 by minus 2i, what's that? Plus 6i. Oh, very nice. Let's take a look what's after happening here. We have 2, take away 3, which is minus 1. We have minus 6i being added onto 6i, and that's 0i. So I'm just going to leave that as minus 1. I'm now going to do question 4, part 5 on page 191. And so this is the setup here. We're told what Z1, Z2 and Z3 are, and then we're told to do this sum here. So we have Z1 take away Z2 plus Z3, and these two are in brackets. So according to BIMDAS, which we saw before, I think I need to put some boxes in there. I have to put that in the same box, and I have to put that into a box. Now, I cannot do this subtraction until I tidy up what's inside the brackets first. So I have to do my B first. So I'm going to do Z1. So that's equal to Z1 take away. And then Z2 is 3 plus 2i plus 1 minus 3i. That's a Z1 there, sorry. So I now can tie that up to be Z1 minus, well, real part with real part, that's going to be 4. Imaginary part, and imaginary part, so that's 2i, take away 3i, that's going to be minus 1i. I'll draw my line. Now we have Z1, which is 1 minus 2i, and from 1 minus 2i, I'm going to take away 4 minus 1i. So that's going to give me 1 minus 2i minus 4 plus 1i. Okay with that? We can see that we have a minus. Taking away a minus, we get a plus in there. So we'll look out for that, okay? An awful lot of people fall into the trap of just putting the minus in front of this 4. And then they continue on as red then. We cannot do that. Both of these things are being taken from these things. So we're taking away a 4, hence we have a minus 4, and we're taking away a negative 1i, hence we have a positive 1i here. So now it's real parts with real parts. So that's 1 take away 4, that's minus 3. We have imaginary parts with imaginary parts, so we're at minus 2i, and we add on 1i, that gets us to minus 1i. And so that is the answer to question 4 part 5. So we had to use a little bit of BIMDAS in there as well. So this will be the last question we're going to do on page 191. There will be other questions that you were assigned to do. So if you got stuck in any of them, let me know on Edmodo and I'll try and get them sorted for you. I suppose these are more examples of what we're doing. I think I did one example of addition, subtracting and multiplying. So it's probably better to have a few more examples in your arsenal. So question 6 part 3. There's a right way of doing this and there's just a way that just makes sense to do this. Let's take a look at maybe the right way to do this now. Okay, so we're asked to find out what Z1 is. And because Z1 is a Z, it's probably going to be a complex number. Or we cannot just assume it's going to be a real number because it is Z. It's kind of hinting that our answer will be complex. It'll have more than one part. Now, this is going to annoy a lot of you because you're probably looking at this and you know the answer already. I just want to do it kind of in a sensible approach first of all, and then I'll look at the more intuitive sense in a second. So Z1 is a complex number. I think I can pretty much guess that it's going to be a complex number. I'm going to make it up into a complex number. I'm going to say that 8 minus 3i, from that complex number, I'm taking away the complex number a plus bi, and that's equal to 3 plus 2i. Oh, I didn't draw my line. I'll draw it there just to be safe. So that then gets us to a stage where we can then go 8 minus 3i minus a minus bi equals 3 plus 2i. And then we have 8. Looking at the real parts, well, that's an imaginary part. And that's an imaginary part. So just looking at the real parts, we have 8 minus a. And that's the real part on the left-hand side. So that must equal the real part on the right-hand side. So when we take a from 8, it must equal 3. So we now know that a, or rather minus a, is equal to 3, take away 8. So to get rid of adding 8 on this side, he becomes negative 8 on that side. We do the opposite on the other side. So that's minus a equals negative 5. So a equals 5. So I've worked out what a is. That's quite nice. Now let's take a look at the imaginary parts to work out what b is. So I have minus 3i, and I take, and that must equal 2i. So I think I did this before. I'm going to factorize out the i's. So I have I times minus 3 minus b equals 2i. So that's the coefficient of the imaginary part, and that's the coefficient of this imaginary part. So that coefficient must equal that coefficient. So minus 3 minus b must equal 2. So minus b must equal 2 plus 3. So minus b is equal to 5. So b must equal negative 5. So that's my a. And that's my b. So my complex number Z1 is equal to 5 minus 5i. So that Z1 is that thing there. So Z1 is what's inside the brackets, a plus bi. So the complex number Z1 must be 5 minus 5i. So that's how to tackle these type of questions. Now, Let's take a look at kind of a more intuitive sense of doing that same question. There's going to be some real number in Z1 that I take away from 8 to give me 3. So what do I take away from 8 to give me 3? 5, okay? Now, what do I take away from minus 3 to give me plus 2? Well, if I take away a positive number, I'll get even more negative, right? If I just take 2i away from 3i, I'll get minus 5i. So that's no good at all. So I'm going to have to take away a negative number to get up to a positive number. So it's definitely going to be a negative in there. Sorry. And crucially, what do I have to take away from negative 3i to get up as far as 2? Well, there's 5 in the difference, so it's going to be negative 5i. So Z1 is equal to that guy there. And we can do that just by thinking about it. You probably should introduce the a plus bi. You probably should use that approach, but I think for this question here, you could really just think about that as your answer. And I would prefer you to start thinking about these things, because realistically this chapter is very, very easy if you're willing to do a little bit of thinking. I'm going to leave page 191 there, and we're now going to move on to page 192. And these were the questions that you had to do when there was multiplication involved. Now, we'll come across the trick. It's not really a trick, but we'll come across the kind of the more difficult aspect to multiplying complex numbers in a second. So let's take a look at this question here. Well, I have this imaginary number here multiplying this complex number. So there's my real part, there's my imaginary part. So let's take a look at how this happens. So I have 3i times 1. Well, that's just 3i. Anything by 1 is just itself. Then I have 3i by minus 5i. So that's going to be positive times a negative is going to be a negative anyway. And 3 times 5, that's going to be 15. And then I times I is going to be I squared. So it's minus 15i squared. Now, in this chapter, we know a particular fact about I squared. I squared is equal to what? What's I squared equal to again? So this whole chapter arose because I squared is equal to minus 1. That's a fact for this chapter. So there's Matthew, Mark, Luke, John, and this thing. Okay, this is the truth. You need to know this, and wherever you see an I squared, you're going to turn into a minus 1. You need to be like a complex number machine almost. So wherever you see an I squared, that gets turned into a minus 1. So we can go one step further here. We can go 3i minus 15 bracket minus 1. That's going to be 3i plus 15. Because we have a minus times a minus to give us that plus. So it's page 192, question 2, done. That's our answer there. In multiplication, whenever we multiply an imaginary number by an imaginary number, this thing here happens. So look out for that. So adding and subtracting were very straightforward. We didn't really need to know anything about complex numbers to do adding and subtracting. But for multiplication, we need to know this bit of theory. We need to know that I squared is equal to minus 1 because it crops up whenever an I hits off an I. So fact, you need to know this, I squared equals minus 1, and whenever we see an I squared, we turn it into a minus 1. This will be the last question from the homework, and it's a multiplication question. And we have this complex number multiplying this complex number. So when complex numbers multiply, this I, at some stage in the future, will bounce off this I, and the result will be, when an I times an I, the answer will be I squared. And we know that we can turn I squareds into minus 1. Okay, that needs to be known. That's a really important fact for complex numbers. So let's multiply this out. So each thing in here has to multiply each thing in here. To make sure we do that, we have a system where the first multiplies the first, so it's 1 by 1 is 1. 1 by I, that's just I. Minus 4i by 1, that's just minus 4i. Minus 4i by I is going to be minus 4i squared. I can do some simplifying here. I have 1 minus 3i minus 4 times minus 1. And it should be like second nature to you that this I squared just gets turned to minus 1. So we now have 1 minus 3i plus 4. So that's going to be 5 minus 3i. So that's page 192, question 8. Please, 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 please look out for I times I equals I squared, and I squared gets turned into minus 1. You might get like half marks for that. Sorry, half marks for that stage. Yeah, you'll get loads of marks once they see you doing that substitution. I squared is the same thing as minus 1.